Now, Michael, you're walking around with that stone in your hand.
The stone. This is the original soil of the property. This is the original clay.
Wow. Oh my gosh.
And now you saw what we've turned it into. Totally different.
Wow. It's heavy too.
Oh, very, very heavy.
Really
very
heavy
dense.
and compact.
Yeah. It's almost fossilized. It's
How old is this piece right here?
Oh, I just dug it out of the ground.
Wow.
Dug it out so that we could see it today.
Wow.
And
so it's really river clay.
Yep, adobe.
Adobe
clay, and it's rich in salt and rich in calcium. And when it's dry, this is, well, roots can't survive in that or penetrate through that very well. If this gets wet, it is awful. You stick a shovel in this and you can't get the shovel back out.
Yeah.
And when it's dry, it's hard as a rock. So you can't grow a forest on this kind of a soil unless you do what I did, and that is add humus. And I'm going to show you this, what happens to clay when humus interacts with it. All right, now, right here, look closely and you can see how you get these clusters. Okay?
Oh.
That's the clay. When humus gets into clay, it causes clay to aggregate or cluster into these little balls, making it very, very porous. You can see all the clustering all over the ground. You see? We've added humus to this site, and just a tiny amount every year for 23 years. On this site, it was done once every year.
Okay.
And we probably won't do it ever again on this site because I don't believe it needs it anymore. Now this is dry. We don't actually water here. Okay, and we haven't had measurable precipitation on this site since probably last September.
Oh wow.
We're in May, and so it's been that long since we've had measurable precipitation. So we're going to dig down here because one of the things that you have to understand about humus chemically is a hydrophilic chemical. Hydrophilic means that it helps to moderate the availability of water in a soil, keeping it available to plants.
Okay.
Okay, and so it keeps the soil moist for a longer period of time. Humus doesn't break down.
Wow.
Whatever humus is in here now will be here 1,000 years from now. Wow. So here we go. You ready?
Yep.
Yeah.
We're going to push this down. Oh, yeah.
Wow. Look at that.
And pop it up.
Wow.
Look at that.
Wow.
And it's moist.
And it's moist. Ultimately, the benefit of humus, by building up the humus content of a soil, the benefit is that it makes a landscape dramatically more drought tolerant.
Right.
Much more drought tolerant. I believe it's going to be that, in combination with the mycorrhizae, are going to be the salvation for allowing us to keep our landscapes green.
Okay. Yeah.
You know, Albuquerque is a big city, and if we cut down all the trees and get rid of all the lawns and turn everything into gravelscapes, Albuquerque is going to get very ugly and very hot. Well, I don't think we have to do that. I think we can do this and be able to keep shade in our yards, and be able to have vegetable gardens and grow our food and grow nutritious food. Humus will make any food you grow in that soil a more nutritious food. It won't be empty calories. It'll be packed with enzymes and vitamins and minerals if we can only get this back into play. Very, very important. Look at the difference between...
Yeah, look at that.
That's pretty amazing.
Huh?
Yeah.
Wow.
This property has only been getting this this transmutation for about 7 years. Technically, it was called a saline sodic alkaline clay.
Wow.
So saline means
Salty.
lots of salts. Sodic means lots of sodium salts, sodium chloride. And alkaline means very high pH. the worst of all conditions.
And so did you end up taking this soil back to those soil scientists and saying, look, I fixed it?
Well, this is very interesting, because if you were to take that soil there and run it into a lab and have it analyzed, what you will find is that it will have a significantly higher level of carbon, particularly the humic acids. Organic matter doesn't tell you anything about humic acids.
Right.
Organic matter is the combustible part of the soil, which means they can burn it. It has a calorie value. So you can measure organic matter in soil or in a compost, and you can measure humic acid content, which is your humus part of the equation.
Right.
And remember, since humic acid can last in a soil for 1,000 years, as long as we don't plow it, rototill it, disturb it, we don't want it to erode away. It can last 1,000 years, and the reason why is because it has no calorie value. It is not a source of food for microbes, so they're not going to eat it and break it down. It's not going to decompose. Where organic matter, like compost, peat moss, straw, that does have a calorie value. It will break down. It will be consumed.
Humus has no calories, and it's not absorbed. It's not absorbed by microbes.
It's not eaten.
It's not eaten.
Not consumed.
Wow.
It's not going to decompose. That's all microbes are doing anyway. If you have fungi that are eating this piece of wood, all they're really doing is decomposing it.
So you never tilled any of this soil. No. You left it clay, and you just put humus on top of it.
Just on the surface. But I didn't mulch over here. This is that's why I wanted you to see this.
Right, yeah.
This is an example of humus formation where we didn't have the benefit of all that. Look at that.
Yeah, it's amazing.
We didn't have the benefit of all that.
The mulching and the leaf litter.
Yeah.
This humus sprinkled on here made
humus
this.
And protein.
Humus and protein.
Yeah.
Okay.
Yeah, protein is again the protein that we derive from the beans.
Right. Okay.
And
you sprinkled the beans on here when you were
not
done.
Not the whole bean.
Oh, okay.
Just the gluten.
Oh,
part
just
of the bean.
gluten. Okay.
Right.
Wow.
So, and it's interesting in that purely by accident again, one of the things that happened is the idea of this glomalin protein that I told you about earlier wasn't discovered until 1996 by scientists that work for the USDA Agricultural Research Service. And we were using this bean protein long before that. I understand the need for the proper ratio of amino acids for good nutrition. And so my goal was to find a protein supplement, if you will, for the soil by complementing different kinds of proteins in order to get the proper ratio of the amino acids. There's no more knowledgeable person to talk to for guidance to know what is the best ratio of amino acids for a soil biosphere. I based my program on human diet, human physiology. So I made a protein material by matching what humans would need for a perfect diet.
Wow.
And guess what?
Same ratio?
Same ratios.
Wow.
Same ratios of what humans need for proper diet, and matched almost identically what I have been making all along anyway. Wow.